So what's that? I can't really hear you because it's not really the
I was
sound.
wondering if I could leave like 10 minutes early.
Oh yeah, go for it. That's totally fine. Yeah, no problem. That'll
Okay,
work.
thank you.
All right, no problem. All right, so for the counting principle, permutations and combinations. So in this section or these sections, we're going to learn how to count different ways to do certain things. So for example, if we have 40 people in this classroom, suppose that we need to select 2 people from this class to complete a national statistics tournament. The first one is going to be the leader, and the second one is going to be the assistant. How many different ways can we select 2 people? Let's just make this problem a little more simple. Let's just say we had, let me just actually look at the participants in our room. Let's say we had Pamela, Alejandro, Erica, Jocelyn, and Tori. So that's 1, 2, 3, 4, 5 people, and we needed to select 2. So maybe the first one is Pamela as the leader, maybe Alejandro's the assistant. Or we can say Alejandro's the leader, Pamela's the assistant, or we have Erica's the leader, Jocelyn, so on and so on. So you can make a lot of combinations. So the question is, how many different ways can we come up with a leader and an assistant? But it's not just 5 people, it's actually 40 people. So you can imagine this would be kind of a hard problem to figure out just by pairing up 2 different letters like that, because you can arrange it in all sorts of different ways. So so let's see what they say here. So what we need to know is, let's just backtrack. All right, let's say that we have n is the number of people. That's 40, right? 40 total people. Let's see. The number of people that we need to select is 2, right? A leader and an assistant. And then it says, does the order of the arrangement matter? In other words, if I select Pamela and then Erica, is that different from Erica and Pamela? Are those 2 different permutations?
Yes.
It is arranged different.
Yeah, it is different. So in this case, the order does matter because PE is different than EP. So in this case, does the order of the arrangement matter? Yes, it does. All right, so this is called, whenever the order matters, that means it's a permutation. Permutation, and we'll get into that later. But for now, just write permutation. And that's because, I'll put this in parentheses, order matters. All right, now let's look up the next scenario. The only thing that's changing is it says, let's change the scenario. Once again, we need to select 2 people again from the class, but this time there is no leader, which means there's no assistant. There's no title form them. There is no title form them. I don't know what that means. Title for them, maybe. We just need to select 2 team members. Then how many different ways can we select 2 people? So same thing, we still have 40 people to choose from. We're still selecting 2 people. But in this case, let's say I selected Pamela and Erica. Is that the same thing as selecting Erica and Pamela? Are those arrangements different or are they the same?
They're different.
Different.
Well, remember there's no leader.
But there's
And-
no leader, so it's okay.
So that means that this is the same thing because it doesn't, we're only selecting
Oh,
two
okay.
people. It doesn't matter if Pamela goes first, Erica goes second, or if Erica goes first and Pamela goes second, because there's no leader, there's no assistant, as long as you're selecting 2 people. So these arrangements are the same. So in this case, you're supposed to say, does the order of the arrangement matter? No. Therefore, this is called a combination.
So where did you get the 40 from?
Oh, because it's the same problem. You have
Oh,
40.
it's the same problem.
Yeah, the only thing they're changing is instead of selecting a leader and an assistant, in this case, they're just selecting two team members. So there's no leader, then there's no assistant, there's just two team members. So you guys are both equal players. So therefore, this means that the the order does not matter, which now it's called a combination. So if the order does not, if the order does not matter, that means it's called a combination. Order does not matter. It's called a combination, but if the order does matter, then that means it's called a permutation. So usually, like if they say you're selecting a president, a vice president, and a secretary, then that means the order is going to matter, right? Because you need someone to be specific titles for each people. But if they just say you just need to select 3 members, that means that it doesn't matter which order they come in. So that's where the order does not matter. So you'll see the difference down here. A blank is any ordered arrangement of a given set of objects. So a permutation. It's a permutation because it's ordered. So that's the keyword. All right. So if there's n different items or to choose from, in this case, there's 40 different people to choose from. So that's your n. We're selecting R of the n. That means we're selecting 2 people, right? So that's your R. So you're selecting 2. No repetition. The same item cannot be selected more than once. We consider rearrangements of the same items to be different sequences. Okay. So AB is different from BA because maybe the A is the leader, B is the assistant. That's different from B being the leader, A being the assistant. So how would we solve this problem? Well, this is if we were working out that problem, you would say 40 permutation 2. So from the 40, you're going to select 2 people. So the 40 goes on is the n, and then the 40 minus 2 is in the denominator. And see those exclamation marks?
Yes.
Those are, that's called the factorial. Factorial. So let me show you a couple ways you can solve this. So this is the same thing as 40 factorial divided by 38 factorial, because you got 40 take away 2, which is 38. All right, so let me show you how to do this on the calculator, and then I'll show you how to do it by hand. If you don't have a calculator, that's a a graphing calculator. So this is how you would do it on your calculator. If first you type in the number 40, 40, then you hit math. See this math button? And then you're going to go all the way to PRB. Some of the calculators are just going to say PRB. Mine says PROB. So you scroll to the right until you hit PROB. And then you're going to go down to the second one, NPR. So the second one is NPR. And then you type in the number 2. And then enter. So there's 1,560 different ways that you can select 2 people out of the 40. So that one of them is the leader and the other one is the assistant. So that's a lot of ways. 1,560 is the final answer.
Can you do that again? I was just writing it down. Can you do it one more time?
Yeah, so first thing you
Okay.
do is you type in the first number, which in this case is 40, 40.
0.
Then you hit the math button,
Math button.
and then you scroll to the right until you get to the PR. Some calculators will say PRB, some calculators say PROB. Mine says PROB for probability. And then you look for NPR. And then you hit 2 because you want to choose 2 people,
2.
and then enter.
Okay.
All right. So let's say you didn't have a calculator So let's show you how to do this without a calculator. Have a calculator, right? So at this point, we already know the answer is 1560. So that's how many different ways you can select 2 people out of 4 people to be a president, or what was it? Leader and an assistant. All right, so if you don't have a calculator, you would just do it this way. What the factorial means is that that means that you're gonna multiply all the numbers starting from the number that's in front of the factorial, and you're gonna multiply all the way down to 1. But that's a lot of numbers to write, ... 5, 4, 3, 2, 1. So I just put the ... because it would take me too long to write all the numbers. You can do that too. 38, 37, 36, ... 5, 4, 3, 2, 1. That's what factorial means. That's what the exclamation mark means in math. Obviously, it means something different in English. It means like excitement or something. But in math, it means you're multiplying all the numbers down until you get to 1. All right, and so now what you can do is cross out all the numbers out of the same. So from 38 all the way down to 1, you can cancel them out. And so your final answer is just going to be 40 times 39. So do that on your calculators, 40 times 39, and you should get the same answer we got when we used the calculator function. Everybody get the same thing? So 40 times 39 is 1560. So it's the same thing. So now you have 2 ways to do this. If you have a graphing calculator, you can do the NPR button. If you don't have a graphing calculator, then you have to kind of do it the manual way by hand, but you'll get the same answer. All right, now let's look at the second formula, which is a combination. A combination is a distinct group of objects without regard to the order. So order does not matter. So that was what we were doing up here. Up here, permutation, that's when the order matters. Down here, combination, that's when the order does not matter. So now this is a formula for when the order does not matter. It's basically the same formula. The only difference is that it has the r factorial in addition. So there's an additional r factorial in the denominator. That's the only difference. So they're saying that AB is the same as BA because the order doesn't matter. It's like selecting Pamela, then Erica. That's the same thing as selecting Erica and then Pamela. So yeah, so let's do the same problem. 40, choose 2. So we can do the same thing on the calculator. Let's just plug in the numbers. 40 is your N and R is 2. So 40 over 40 minus 2, 2 factorial. So the only difference is this. Otherwise, it's the same as the previous problem. All right, let's turn the calculator first. So it's the same steps as before. So let's show you the calculator again. So you type in 40 again. And then you hit the math button. And then you go back to PROB. And this time it's number 3, NCR. So it's the same steps. And then you hit 2. And you're going to get a different number. You're going to get a smaller number. 780. So that's how many different ways you can select 2 people if the order doesn't matter. If you're just selecting 2 team members instead of a leader and an assistant, there's less ways.
Mr. Hernandez,
Mm-hmm.
what about the other 2?
The other 2,
You know how it's in brackets and then you have 2?
oh yeah, the calculator takes care of all that for you.
Oh, I see.
Yeah, so it's done. 780 is the final answer. So let's go back to our notes and you will see that we can do it by hand as well. So we can confirm that the answer is the same. Answer is going to be, we already know it's 780, but let's do it this way by hand. Our 40 take away 2 is 38. So you can do the same thing we did before, 40, 39, 38, 37, 36, dot, 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 5, 4, 3, 2, 1. The bottom, 38, 37, 36, dot, 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 5, 4, 3, 2, 1. And then you have the 2 factorial, that's what you mentioned, Erica. So we have to include the 2 factorial, which is 2, 1. So there's your 2 factorial. All right, and let's do the same thing we did above, which is cancel out the same
Thank you.
38 all the way to 1. 38 all the way to 1, cancel out. But don't forget, you still have the 2 and the 1 in the bottom. So now you do 40 times 39 divided by 2 times 1. So it's going to be 40 times 39 divided by 2 times 1. So if you do that on your calculator, you're going to get 40 times 39 divided by 2 times 1 is just 2. So divided by 2 is 780. All right.
Where did you get the 2 from? I'm a little confused in the
Oh,
problem. Where'd you get the- Yeah.
because of the formula, see the R factorial?
Mhm. Oh, because it's 2 R's? Is that?
Yeah, oh, because R is 2. Remember,
R is 2, okay.
R represents how many?
2 would be, R would be 2 all the time?
Just in this problem, But right
Oh.
now, we're gonna
Okay.
look at different examples, so
Okay.
you'll see, yeah.
R would be 2.
So N represents how many people you're choosing from, like the group size, and then R represents how many people you're gonna select.
Okay.
All right. So then they give you a little mnemonic to help you remember. So poconos. Does order matter? Permutations, yes. Combinations, no. So permutations, I don't know. I don't understand that mnemonic, to be honest. I just remember that permutation means the order does matter. Combinations means the order does not matter. I think I just memorized it over time, but I don't know what this means. Permutations, order matters. Combinations, no. Oh, I guess that's what it means. So combination does not matter, no. Permutations, it does matter. Anyway, so hey, let's look at some examples. How many different ways can the letters be arranged? The order matters, right? Like if you have A, B, and C. So let's just write them out. A, B, C. A, C, B. B, A, C. B, C, A. C, A, B. C.
Well,
B.
Professor.
Yeah.
It says only 2 letters are selected, so.
Oh, you're right. Oh, yeah, thank you. So, yeah, thank you. So A, B, A, C, B, A, B, C, C, A, C. Any others? I think that's it.
CB.
CB. Oh, you're right. Yeah, CB.
Isn't
Okay.
that BC? I mean CB? Oh, yeah, yes. Isn't that C? Or no?
These two.
No, the one AC, where it says AC.
Oh, I already have that one. You're right. Thank you.
All right.
So let's do that. Yes, CB. So I think there's going to be 6 different ways. Let's confirm it using the formula. And how many different ways can the letters be arranged? Order matters. So is that going to be a permutation or a combination?
Permutation.
Permutation because the order matters. Yeah, that's right. So let's do that. So that's a permutation. I'm just gonna write that word. All right, so N, anybody know what N represents in this case? How many letters are there to choose
This how
from?
many letters there are?
Yeah. 3, right? A, B, and C.
Yes,
And then R represents how many letters you're choosing.
so 2.
2. And then which of the two? We said it is a permutation, right?
Permutation.
Because it says order matters. All right, so now we can actually solve it. So NPR is going to be 3P2. If you use a formula, then you would go back to here and you would plug in the numbers here. So it would be 3 take away 2 factorial. So it's going to be 3 take away 2 factorial. All right, which is just 3 factorial over 1 factorial. This one's kind of easy because the numbers are small. 3 factorial is just 3 times 2 times 1. 1 factorial is just 1. You can cancel out the ones. The answer is
6.
6. And that's exactly what we got, remember? 6 different ways. 1, 2, 3, 4, 5, 6. Cool, so we did it right. All right, now let's look over here. It says, how many different ways can the letters be selected? The order does not matter this time. So if the order doesn't matter, do you guys agree that these two are the same?
Yes.
So that means we would get rid of this one. These two are the same. So we would get rid of this one. And these two are the same. So we would get rid of that one. So the answer should be 3. Let's see if it's correct. So this is going to be a combination. There are 3 letters. We're selecting 2. So it's going to be NCR. So the formula, once again, is over here. It's the same formula. You just have to remember to add the R factorial in the denominator. So 3 factorial, 3 minus 2 factorial, and then 2 factorial. All right, well, that's the same thing as 3 factorial over 1 factorial, 2 factorial. And then you can write them out. 3, 2, 1, 1, 2, 1. All right, and then you can cancel out the numbers that are the same. 2 and 1, 2 and 1. And your answer is going to be 3 divided by 1, which is 3 different ways. And that's exactly what we got. 1, 2, 3 different ways. So that's the way the formulas work. So what do you guys think? Is this kind of challenging or is it doable?
We
It's
shall see.
challenging.
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 Yeah, especially in the beginning because we're introducing new notation and these formulas look a little scary. But once you do a few, I think it should get a little easier. Let's look at the next one. It says Nancy has 10 different flowers from which she will choose 6 to use. How many? So let me underline the numbers. 10 different flowers. She's going to choose 6 of them. How many different ways can she do it if the order of the flowers does not matter? So first thing you should ask yourself is it a permutation or a combination?
Combination.
Combination.
Combination because of the order does not matter. All right, and then ask yourself, what is N? How many different flowers are we choosing from?
10.
6.
10.
10,
Well,
sorry.
Yeah, and then R is how many flowers we're actually
R
choosing.
is 6.
Or 6.
Yeah, it's always going to be the bigger numbers always N, the smaller numbers always R. So that's just the easy way to remember. So there we go. So we got N equals 10, R equals 6 at 10 choose 6 is our problem that we need to find. And you can do it 2 ways. If you have a graphing calculator, I would recommend just doing the calculator way. It's way faster. So let's do that one more time on our calculators, just so that we get used to that if you have one. So hopefully, if you have one by hand as well. So back, remember you type in the number 10. Then you go to math, PROV. And this time it's a combination, which is number 3. And then 6. And that's going to tell you how many different ways you can select 6 flowers out of 10 when the order does not matter. 210 different ways. All right. And if we do this by hand, so we already know the answer is 210, but let's just do it by hand. This time it's going to be 10 factorial over 10 minus 6 factorial over 6 factorial. So that's going to be 4 factorial. And then you can write this out, 10, 9, 8. You can do the dot, dot, dot like I am, 3, 2, 1. Or if you want, you can just write out every single number. 4 is going to be 4, 3, 2, 1. 6 is going to be 6, 5, 4, 3, 2, 1. All right. Maybe I should have written them all out because it's going to be a little bit difficult to see what I'm crossing out. So let me just write them all out. All right, and now you can cancel out 6 through 1, 6 through 1. All right, and you can even do what I'm about to do. You can simplify. 4 goes into 8. How many times? Twice, right?
Yes,
3 goes into 9. 3 times.
3 times,
2 goes into 10. 5.
5 times.
So now you just have 5 times 3 times 2 times 7, and that's your answer. So 5 times 3 times 2 times 7 is 2. You guys get the same answer as we got on the calculator? Yeah, you should. You should get 210. So as you can see, you will get the same answer. So if you have a graphing calculator, highly recommend just doing it the way we did it first. But if you don't, then you just have to get comfortable doing it by hand. All right, let's look at the next problem. The next one says, if a club consists of 10 members, so that's your N, right? How many different arrangements of president, vice president, secretary are possible? So do you guys think it's going to be order matters or order does not matter? So if I go Alejandro, Tori, Jocelyn, is that the same thing as Tori, Alejandro, Jocelyn, or is that different?
It's different.
Yeah, because this is president, vice president, secretary. Notice that the presidents are different, the vice presidents are different. So these are different. That means the order matters. So order matters, which means you have a permutation. So now we have N equals 10, right? R, how many people are we selecting?
3.
Yeah, 3, because we need a president, a vice president, and a secretary. And so this becomes a permutation problem, 10P3. All right, so 10P3. You guys can do that on your calculators if you have one. If not, I'm going to do it by hand. So the formula is this one. Okay, so that would be n factorial n minus r factorial. So that's just going to be 10 factorial divided by 7 factorial. And if you write them all out, you will see that you're going to get a lot of numbers. You're going to get the whole denominator to cancel out 7 through 1. And so your answer is just going to be 9 times 8 times 10 times 9 times 8, which is 720, right? All right. So there you go. There you have it. Anybody have questions on these problems so far? All right. Well, the good thing is I'm recording it. So if you need to kind of like go back and watch it again, you guys can always do that. Let's look at actually number 4. I'm going to let you guys try this out. So I'm going to give you guys like 3 or 4 minutes. So you guys can, I'm going to just pause the recording and put it on mute so you guys can look at it and try it out. And if you want to talk to each other, you can feel free to talk to each other to help each other out. All right. So let's see how you guys did on this one. All right. So anybody get whether this is a combination or a permutation?
I think it's a combination.
Yeah, that is right. Because the order does not matter. Order.
Finish it. I got like down to the, when you're doing it by hand or could do it on the calculator. I
Mhm.
think I pretty much got this one, but I didn't finish it.
All right, that's all right. Let's see if you're on the right track then. So 20 members. Do you guys agree that that would be your N?
Yeah,
All right. And then R, what would R have to be?
4.
Yeah, because you're looking to select 4 members, and it's a combination because it does not matter who goes first, second, third, or fourth. There's no like titles like president, vice president, or assistant, leader, or nothing like that. So that means combination. So it's going to be 20.
20.
Whoops,
uh,
20 choose 4. So the C, sometimes people say 20. Yeah, people usually say 20 choose 4 for C. All right, so 20 choose 4. You can use your calculator or the formula. If you use your calculator, I recommend using the calculator just so that you know what the answer is for sure. And then you can also do it by hand if you want. So I'm going to do it by hand. 20 factorial on the top divided by 20, take away 4 factorial divided by 4 factorial, right?
Right.
So that's going to be 16 on for 20 minus 4, and then 4 factorial. So this one, I'm only going to go up to 20 times 19 times 18 times 17. Here's another trick you can do. You can just stop at the biggest number in the denominator. See how I stopped at 16? And then you can just put a factorial at the end of 16 instead of going all the way to 15, 14, 13, all the way to 1. You can just stop here because it's the same as the bottom. And then you can cancel those out. So that's another little trick that you can use. You don't have to expand it. You do want to expand the 4 factorial. 4 was 4, 3, 2, 1. But you don't have to expand the 16 because the 16 factorials are going to cancel each other out. So the trick is just expand the top until you get to the biggest number on the bottom. And that's where you stop and you put that factorial symbol. And then you can cancel. That way you save yourself some time of writing all those numbers down.
The
And
reason
then
why I started at 4 because it is at the factorial.
this one, yeah, I started at 4 because that's the number in front of the factorial. 4, 3, 2, 1.
And I can
And
do
then-
the rest of them like that. What about the permutations? Can I do that one like that too?
Exactly, yeah, you could have done that. So over here, all you had to do is go like this. 10, 9, 8, 7 factorial, 7 factorial. you don't have to go all the way to 1 because these two are going to cancel out. Then you'll get the same thing, 10 times 9 times 8, which is the same thing. You just save yourself the trouble of writing all these numbers out. All right, so over here, you can do this on your calculator, this number divided by this number. Or you can start canceling terms out too. I like to cancel. 4 goes into 20 5 times. 3 goes into 18 6 times. 2 goes into 6 3 times. And so now the answer is just going to be 5 times 19 times 3 times 17. It's just this number times this number times this number times this number. All right, so let's see what that gives us. I'm getting
845.
4,845 different ways that you can do that. All right. Yeah, it sounds like a lot because there's only 20 people you're choosing from and you're selecting 4 out of the 20. And you wouldn't think that there's this many ways that you can select, but that's the number of different ways you can select 4 people out of 20. So it's pretty crazy to think that that number should be so big, but it is. All right, so let's move on. There's a couple more examples. Maybe we should take a break soon. Maybe we'll do one more problem and then we'll take our break. So let's do one more. There are 20 members on the board of directors for the Long Beach General Hospital. If they must select a chairperson, so we know N, they need a chairperson, a vice chairman, and then a second vice chairperson, and a secretary. So what do you think? Is this a permutation or combination?
Permutation.
Definitely permutation because the order matters.
2, 3.
So we know N is 20. How many people are we selecting?
3.
1, 2, 3, 4 actually, right?
Oh, wait a minute. Oh, chairperson, I forgot that.
Yeah, there's 4 people. So that's R equals 4. And we said this is a permutation, so 20P4. So once again, don't forget you can do this on your calculator. Otherwise, the formula is N factorial over N minus R factorial. So that's going to be 20 factorial divided by 16 factorial. And remember the shortcut? How far should I go on the top? How up to what number should I expand?
16.
Yeah, you only have to go up to 16 and then you can stop and put a factorial. And then you don't have to expand the bottom because all you have to do is cancel out the 16 factorials. So cancel. Oops. Cancel. Cancel. So your answer is just going to be whatever that gives us. So let's do that on our calculators. 20 times 19 times 18 times 17 is, wow, 116,280 different ways that you can select 4 people out of 20 when the order does matter. So it's a lot of different combinations or permutations, I should say. All right, this is a good time for a break. Let us resume. Let's look at this next problem. It says there are 15 dogs entered in a show. So 15 is going to be your N, right? How many ways can first, second, and third place be awarded? So is this a combination or a permutation? This time order does matter, which makes it a permutation. So N is 15 and R is how many dogs are we selecting 3 dogs. So this is gonna be 15p3. All right, so that's gonna be 15 factorial over 15 minus 3 factorial, 3 factorial. So that's gonna be 15 factorial over 12 factorial, 3 factorial. But remember the trick, we only have to expand the top until we get to 12. You don't have to go all the way to 1. So 15, 14, 13, 12. Put the factorial at the end of the 12. And then that way you can keep the 12 factorial without expanding it. And then 3, you do want to expand 3 factorial. That would be 3 times 2 times 1. And the shortcut allows us to cancel these 2 out. And now all we have to do, we can do this on our calculator. 15 times 14 times 13 divided by 3 times 2 times 1. Or you can simplify. 3 goes into 15 5 times. 2 goes into 14 7 times. And that's it. So your final answer should be 5 times 7 times 13, which is, oh, wait a minute. I got the wrong formula, don't I? I don't need the 3 factorial. That's for combination. Whoops. I almost made a mistake. Permutation is this one. See how there's no r factorial? I was doing this formula. I meant to do this one. So going back, yeah, it's just 12 factorial, not the r factorial. So just cancel, cancel. Your final answer is going to be just these 3 numbers multiplied. 15 times 14 times 13, which is 2,730.
So when it say permutation, we only have to put the, let's see, the what do you call that? The 12 on the bottom? Then the-
Yeah,
Oh, okay.
you don't need to put the 3 factorial. That's only if it was combination. Yeah. So yeah, just be careful. It is open notes, so you can always look at your notes if you have to. All right. This next one says, how many ways can the letters of the word ABC be arranged? Okay, well, we kind of did that problem already, but this time, instead of choosing just 2 letters, they're saying all 3 letters, basically. So your N is 3 letters. Your R is also 3 letters. Because you're choosing from 3 letters and you're choosing all 3 of them to rearrange them. So how many different ways can we arrange them? The order will matter this time. Order matters. Because ABC is different from CBA, right? That's a different, these 2 would be counted separately. So therefore the order does matter. So this is going to be NPR or 3P3. All right, so 3P3 is 3 factorial over 3 minus 3 factorial. So this one's interesting. You're going to have 3 factorial divided by 0 factorial. By definition in math, we didn't say this, but 0 factorial is actually equal to 1. So that's something you should remember. 0 factorial is always equal to 1. So that means at the bottom is 1. So 3 times 2 times 1 over 1. Cancel, cancel. The answer is 6. All right. All right, so that's how you do that. All right, let's look at the next one. And how many ways can the word ABA be arranged? This one's interesting. ABA. All right, let's see if we can figure out this one. Well, let's see. So this one's a little bit interesting. All right, so for this one, let's see, let's just actually write them out. So you can write A, B, A. You can have A, B. You can have B, A. Is there any other ways to write that, or is that it? I believe that's it, right? There's no other ways you can arrange that, those letters. Okay, so whenever you have this kind of a problem, you don't even have to think about permutation combination. This is an easier way to do a problem like this.
What about BAB?
B, A, B. B, A, oh, but there's only one B.
Only one B.
Oh,
and
I
two
see.
A- Yeah, and two A's. All right, so when it comes to these kind of problems where you have to arrange words, just count the number of letters there are. There's 3 letters, 1, 2, 3. That's gonna be 3 factorial. But then you have to divide out the repeats. So there's 2 A's. So you have to divide by 2 factorial because there's 2 A's. 2 A's. 3 total letters. So that's what they're saying here. It's called the permutations rule. When some items are identical, then there are n different items. There's 3 different items, 1, 2, 3, A, B, A. We select all of the n items, n factorial, and then we consider the rearrangements of distinct items to be different. So then you just divide by the number of repeats. So the A repeats twice. So you have to divide by 2 factorial. All right, so the final answer is going to be 3, 2, 1 over 2, 1. There it is. The answer was 3. 1, 2, 3. So let me give you another one. Let's look at Tennessee. T-E-N-O. Anybody know how to spell Tennessee? Am I missing an N? I think so, huh?
Yeah,
Is that right? I think that's right.
right.
All right, so for this one, how many total letters are there? Looks like there's 8. There's 8 different letters. And then how many repeats are there for E?
3.
3, so you have to divide by 3 factorial. And then how many times does N repeat?
2.
Yeah, so 2 factorial. How many times does S repeat? 2. And I think that's it. We got the E, we got the N, and we got the S. You don't need to do T because T doesn't repeat. I mean, you could do 1 factorial, but that doesn't do anything. So that's it. That's going to be your answer. So you can just write them all out. Three, 2, 1, 2, 1, 2, 1. So this is for the letter E. This is for the letter N. And this is for the letter S. All right, so cancel out 3, 2, 1. 3, 2, 1. And then you have 2 times 2 is 4, right? So 2 and 2 cancel out with 4. And so your final answer is just going to be 8 times 7 times 6 times 5. 8 times 7 times 6 times 5, which is 1,680 different arrangements. So you can scramble these letters and make different words. you can make 1,680 different words if you scramble up these letters. The words aren't gonna make sense. For example, E-N-T, you get the idea. This is a little hard to do, but you can rearrange all these letters. This is how many words you can make, even if the words don't make sense. So 1,680 different ways to scramble those letters up. All right, let's go see if there's anything else to do. Oh yeah, same thing. I think this is the last page. Oh no, there's more. Holy cow. We might have to break this up and look at this next class. All right, let's see how far we can get, because I think the class ends in like 3 minutes.
Yeah,
All right, let's just do one more problem. All right, statistics. In how many ways can the letters of the word statistics be arranged? So how many total letters do you see there?
I think it's 10.
I think it's 10, yeah, 10 total. Divided by, and then anything repeat, what letters repeat?
S,
S would be 3 times, right?
yeah,
So that's your S. All right, anything else repeat? T,
T,
3 times as well.
I,
I, 1, 2. All right. Anything else repeat? A, no. I, oh, we already got that one. S, we already got that one. T, we already got it. C, no.
no,
So that's it. So at that point, you would just write them out. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 3, 2, 1, 3, 2, 1, 2, 1. And then cancel out the 3, 2, 1. 3, 2, 1. And then look at that. 3 times 2 is 6. So you can cancel out the 6 with the 3 and the 2. So 3 and 2 makes 6. And then the 2 goes into the 4 2 times. 2 goes into 4 twice. So your final answer is going to be 10, 9, 8, 7, 5, 2. All right, so let's see what that turns out to be. 10, 9, 8, 7, 5, 2. I'm getting 50,400 different ways to arrange those letters. All right, so we have run out of time, but we will continue this next class.
Oh,
I know,
that sucks.
it sucks because this is so fun, I know.